Hi everybody, today I'm doing a problem about scrapping or reworking parts that requires us to use the normal distribution. And in this video, I'll use Minitab for our calculations. A factory produces metal rods that must meet strict weight specifications. Each rod must weigh between 9.8 kilograms and 10.2 kilograms to be considered acceptable. If a rod weighs less than 9.8 kilograms, it is scrapped. If a rod weighs more than 10.2 kilograms, it's reworked. Given that the weights of the rods are normally distributed with a mean of 10 kilograms and a standard deviation of 0.15 kilograms, we're going to find the percent of rods that are expected to be scrapped. So this means we're going to do a normal distribution with a mean of 10, a standard deviation of 0.15, and we're looking for what percent of the rods are less than 9.8. If they're less than 9.8, we're going to scrap them. So in Minitab, I'm hitting Graph, Probability Distribution Plot, View probability. I say OK. We're using a normal distribution where we had a mean of 10.0 and our standard deviation was 0.15. Now we hit options and we have a specific x value. So we had specified x value on the left and our x value was 9.8. We hit OK and OK. The graph shows us that when our mean is 10, our standard deviation is 0.15, we'll have 0.09121 or 9.121% less than the value of 9.8. That says 9.121% of the rods will be scrapped. Next, we'll find the percent of the rods that must be reworked. So we're going to keep our mean, we'll keep our standard deviation, but now we want to switch to a right tail because we're looking at more than 10.2. In Minitab, again, I hit Graph, Probability Distribution Plot, View Probability, OK. Keep my mean, keep my standard deviation, hit Options. Again, a specified x value, but this time on the right, and our value is 10.2. We hit OK and OK. Now we can see greater than 10.2 is also 9.121%. So we have these equal values left and right in this particular situation, but remember it could be different depending on the numbers you're given. So now that we know we have 9% on the left, 9% on the right that are either being reworked or scrapped, we want to redo this process. We want to know how the process can be centered to eliminate all but 0.15% of the scrap. We'll keep our standard deviation of 0.15 kilograms, but we want to find a different mean. Remember, 0.15% is really 0.0015. We want to find the z-score that has 0.0015 to the left. We have to use the z-score when we don't know x bar. So we're going to go back to Minitab and look for the z-score that has 0.0015 to the left. So Graph, Probability Distribution Plot, View Probability. This time, switch back to the mean of 0, and then a standard deviation of 1. In the options, we're going to a left tail for a specified probability, and that specified probability is 0.0015. Now we say OK and OK. This is very small on the left, but you can see the 0.0015 and a little bit of shading. What we want to grab is the z-score of negative 2.968. Now that we have our z-score, let's look back at the equation for z. It's x minus x bar over s. We know that z is negative 2.968, x is 9.8, our standard deviation is 0.15, and we're looking for x bar. We just need to rearrange this equation and solve for x bar. We'll start by multiplying negative 2.968 by 0.15, then we'll isolate the x bar. This gives us an x bar equal to 10.2452, which I'm just going to call 10.245. Now that we have our new center, we have one more question to answer. What is the rework percentage now? What this means is now that we have a different mean with our old standard deviation, do we have a different amount of rods that we're going to have to rework? Back in Minitab, I hit Graph, Probability Distribution Plot, View Probability, OK. Change the mean to our new mean of 10.245. 0.245, standard deviation 0.15, options. Now we're going to go on the right of a specified value, and this specified value is our 10.2. We're going to say OK and OK. Because the 10.2 cutoff is lower than our new mean of 10.245, we can see that over half of the rods would have to be reworked in this new scenario. We got 0.6179. So to finish off, we'll write 0.6179 as 61.79%.